Hello dear student, once again I welcome you in digital learning session of analog communication. So in last lecture we have seen the uniform distribution function, and we also take one example while number of random variable uniformly distributed for a range 0 to 10. So we have seen the probability of individual random variable or a set of random variable in between this range from 0 to 10. So today we are going to start our next distribution function, so that is exponential distribution function. So this exponential distribution function, its expression can be written as fx is equals to, it is 1 upon a e to the power minus x upon a for x greater than or equals to 0, and for x less than 0 it will be 0. So we may draw this distribution function. So for the x-axis we have small x, y-axis we have fx, and this 1 upon a e to the power minus x upon a is for x greater than or equals to 0. So it is exponential decrement with respect to x, and at x equals to 0 its value will be 1 upon a, and for x less than 0 it will be 0. So this is exponential distribution function, or we can say that exponential decay function, because it is e to the power minus of x upon a. So now I am interested to find the statistical averages of this distribution function. So as we know that the statistical averages are mean, square mean, variance and standard deviation. So we will see these statistical averages one by one for this distribution function. So first I take the statistical average, that is mean, so which is denoted by m1, and its formula, as we know, it is from minus infinity to infinity x dot fx dot dx. So for this function this limit will be 0 to infinity x dot 1 upon a e to the power minus x upon a dot dx. So this 1 upon a is constant, bring it outside, integration 0 to infinity x dot e to the power minus x upon a dot dx. So this is the integration by parts. We can solve this expression. So that is 1 upon a. So first function, integration of second function, so that will be integration of e to the power minus x upon a, so that will give you e to the power minus x upon a upon minus 1 upon a, and this is for the limit 0 to infinity minus integration 0 to infinity differentiation of first function, so differentiation of x is 1, and integration of second function, so that will be integration of e to the power minus x upon a, so that will give you e to the power minus x upon a upon minus 1 upon a dot dx. So 1 upon a as it is. Now if you solve this for the upper limit infinity, this e to the power minus infinity will be 0, and for lower limit 0 this x will be 0. So this complete part will be 0 for the limit 0 to infinity. So now solve this portion. So this minus minus will become plus, and integration is from 0 to infinity to the power minus x upon a upon 1 upon a. So this 1 upon a is constant, so it is a integration 0 to infinity e to the power minus x upon a dot dx. So this a cancel, you will have integration of e to the power minus x upon a dot dx for the limit 0 to infinity. So this will give you e to the power minus x upon a upon minus 1 upon a for the limit 0 to infinity. Now when you substitute the limit, so this e to the power, this will be e to the power minus infinity upon minus 1 upon a, and minus minus will become plus e to the power 0 upon 1 upon a. So this is 0 and this is 1, so this will be, when we solve it, we will get a. So the mean of the exponential distribution function will be a. Now we are solving the second statistical average, that is square mean, and it is denoted by m2. Its formula is minus infinity to plus infinity x square dot fx dx. So in our case it is 0 to infinity x square dot 1 upon a e to the power minus x upon a dot dx. So this can be solved by integration by part. So 1 upon a is constant, bring it outside. So first function is x square, integration of second function, so that is e to the power minus x upon a upon minus 1 upon a, and this is for the limit 0 to infinity minus integration from 0 to infinity, differentiation of first function, that is x square, so that will give you 2x, and integration of second function, so that e to the power minus x upon a, that will give you e to the power minus x upon a upon minus 1 upon a dot dx. So again this portion will be 0 because of the upper limit and lower limit. When we substitute upper limit, this portion will be 0, and when we substitute lower limit, this portion will be 0. So entire will be 0. So we will have 1 upon a, and this is minus minus plus, 2 is constant, so it will be outside, so this is 2, integration 0 to infinity x dot e to the power minus x upon a upon 1 upon a. I am writing here, so it is outside a dot dx. This a cancel, so you have 2 outside, and again now you have to integrate it. So first function is x, integration of second function is e to the power minus x upon a upon minus 1 upon a, and this is for the limit 0 to infinity, and minus integration of 0 to infinity, this will be 1, so e to the power minus x upon a dot dx. So again this will be 0, and when you solve it you will get, this is 2. So here it is minus 1 upon a because 2 integrations are there, so 2, this minus minus will be plus. Again when we perform the integration, so it is e to the power minus x upon a upon, and this is 1 upon a and minus 1 upon a. When you multiply it, so you will get 1 upon a square, and for the limit 0 to infinity. So when you substitute the limit, you will get minus minus plus 1 upon a square in the denominator, and 2 will be in the numerator, so this will be 2a square. So the third is variance, and variance will be sigma square, and that is nothing but m2 minus m1 square, so that is 2a square minus this is a, so a square, that means variance is a square. And fourth is standard deviation, so that is root of sigma square, so that is nothing but root of a square, and it is a. So likewise we can calculate the mean, square, variance and standard deviation for the exponential distribution function. So thank you.